Okay, so for question 3, so question 3 was the first content question of the exam, and it's on scaling. So it's, this question is sort of linked pretty closely to one of the scaling pre-test questions, thinking about tiling 2 rooms and having boxes of tiles. So in that case, it's different, a little bit different, that it's this time we're pouring a volume of liquid. But very similar to that example. I've also seen some other examples with sort of pizza questions where we're keeping the crust depth constant. So both of those sort of questions that you've seen previously are linked to this particular exam question. So so in this case, it's 2 different rooms. They're square in shape. One has a side length L, the other has a side length 3L. But there's also this additional sort of challenge in that there's not forgetting about the number of barrels used in each room. So I'll start here and make sure you can see this. Okay, so question 3. So I'll sort of draw a three-dimensional view of sort of floor A. Hopefully I won't have drawn it too big here. So this is L by L, so it has a floor surface area of L squared, and it has some depth D. So I can see that the volume of the floor, this sort of concrete, this special liquid, is equal to L squared times D. Now I won't be able to draw it to scale here, otherwise I'll run out of room. Hopefully you can forgive me for that. That room B has also got a floor of depth D, so we hold the depth constant. So that's what the question states here. If the floors in both rooms are designed to have the same depth, then this one is 3L by 3L. So we're going to scale the surface area of the floor by a factor of 9, 3L by 3L, and it's the same depth D. So this is similar to that tiling question where the tiles are the same thickness, or you have pizza questions where the crust depth is the same thickness. So the volume of floor B is 3L by 3L, which is 9L squared times D, which means L squared D is the volume of A. So the amount of, we need 9 times more volume to pour the floor for room B. So this is 9 times the volume of A. Now we're told that A requires 5 barrels of liquid, so the volume of A is equivalent to 5 barrels. We know that the floor B, room B, will require 9 times that volume, so the volume of B is going to be 9 times 5 barrels, which is 45 barrels. So that's the correct answer. So the number of barrels we need to form the floor in room B is 45. So that makes that choice B in this, or like the second one down in this particular randomized version. The numbers, just to go through the distractors and to kind of to be wary of distractors to make sure you follow the question through. Of course, 9 is there because that's the factor by which we change the volume, but to not forget about that, it's not just 1 barrel in A, but it's 5 barrels in A. 27 would be 3 cubed. Again, we're not scaling all dimensions, so volume only scales with L cubed if you scale all 3 dimensions by the same factor. Here we're just changing the side length and keeping it a square room, but we keep the depth constant, so that's again another sort of challenge to this question. 30 would be 2 times 3 rather than 3 squared. 45 is of course the correct answer. 135 is doing 27 times 5 barrels, but that would be true if we made the depth also 3 times the depth as we would in A, but the question states that the depths are definitely the same, so that makes the 45 as the correct answer. Now there was a second version, I think it was either 4 barrels, but again if you change the and again if you square the factor by which the room length changes by and multiply that by the number of barrels in A, you should find the right answer in the other version. Okay, I'll wrap up the video there and move on to question 2.